In the last little version, we did the simplest possible thing, and that was we had a simple rotation around the x-axis, and we were given initially the formula in terms of x, and all we had to do was plug into our pi r squared dx, and we were done. Let's just make it a little more complex now, because trust me, Rogi is not going to make it this easy. Let's say we were given all this information, but at the last second the test says, oh, and by the way, we're rotating around the y-axis not to get the projectile shape, but to get this strange kind of cone-shaped object here. Now, we're rotating around this axis, therefore the thickness of the disk is in the y direction, therefore we've got a dy. If we've got a dy, our equation must be in terms of y, but we come over here and it's in terms of x. How do we get the equation in terms of y? Well, in this case, we just reverse it and say, let's square both sides. So we get y squared is equal to x. And now we've got our equation. And we can see from the point of view of the y-axis, this curve is indeed y squared. Okay, so now we come down here. Unfortunately, we got to come way down here, and we say, hey, we've got to integrate. And what is our bounds going to be? Well, before it was 0 to 4, but on the y-axis, this is 4. Square root of 4 is 2. So let's just make it kind of symmetrical, and we'll say from 0 to 2 on the y-axis. We could have picked anything, I suppose, but let's make it 0 to 2. And now we know we've got a dy here. We know we got a pi here. We got something in here, and what that something is going to be is y squared. And that's the radius at that point, but we've now got to square that because that's our equation, pi r squared. Okay, so we just let's just do that, and we get 0 to 2 pi times y to the 4th dy, and this is equal to pi times y to the 5th divided by 5, evaluate it from 0 to 2. Oh, I'm going to get in trouble here. I don't know what y to the 5th is. Let's see here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. We get 32 fifths pi as our answer.